So I want to go over how to get the critical points from the partial derivatives. So you see you take the partial derivative of the function in terms of x and the partial derivative of the function in terms of y. So the typical approach on this is to solve for one variable in one function and plug it in the other function. So here we have 3x squared minus 18y equals 0. If we solve for y, we get 3x squared equals 18y. Divide both sides by 18, and we end up with y equals x squared over 6. Now if I plug that into the second equation for y, I get 3x squared divided by 6, the quantity x squared divided by 6 squared minus 18x. Solve for when that equals 0. So I get 3x to the 4th over 36 minus 18x equals 0. So that simplifies to x to the 4th over 12 minus 18x equals 0. So if I pull out an x, I have x cubed over 12 minus 18 equals 0. So x equals 0, or x cubed equals 18 times 12. So x cubed would end up being 18 times 12. $216, and the cube root of that would end up being 6. So if x is 0 or 6 would be the possible outcomes if you use the function and plug in x to be 0. What would be the corresponding y to solve the to solve the two possible values for, well, in this case, if x is 0, then y has to be 0. So you get the point 0, 0, right? You plug in x equals 0 to the functions. And then the point, in this case, 6, 6. So if you plug in x equals 6, then y has to equal 6. So for 6 squared minus 18y equals 0. So if x is 6, then y ends up having to be 6. You could also see that from plugging in x is 6, 6 squared over 6 is y. So that gives us 6. A few different ways to look at it to find the y value. And you can plug it in from here. Plug it in from here, any of that is going to work. So that gives you the 2 points. Hopefully this answers your question. Sorry on the delay. Please let me know if you have any other questions.